Hi guys, welcome back to my channel. This is going to be another question today. This time it is an easy category question according to lead code, and the question is LC-543 diameter of a binary tree. Now this is a comparatively easy question. I'm going to go through like how I approach this question, and it makes it easier to code and consider all the test cases. So yeah, without wasting time, let's get started. Okay, so basically, you have to find the diameter, and you're given a binary tree. So you should be very clear about what the definition of a binary tree diameter is. Okay, and according to this question, it is the length of the longest path between any two nodes in a tree, and it is not necessarily that that length has to pass through the root. It can be that the diameter of the tree exists in the left subtree, or the diameter of the tree exists in the right subtree. So anyways, it can be the answer, a possible answer. It just has to be the maximum. Okay, now let's say that in this question, this is the given binary tree, right? And what is the answer? How will you find that? So if you actually observe the longest path between any two nodes, it may pass through the root or it may not pass through the root, is actually going to be 3. How? So let's say you consider 4, then you go to 4 to 2, distance 1, then 2 to 1, distance 2, now 1 to 3, distance 3. So this is the longest path that you can ever get, right? So for this case, the answer is 3. But let's say that you are given any generic binary tree, right? Now, how will you calculate the answer for it? So my thought process goes somewhere like this, that let's say that I am at the root. If I get the height of the left part and the height of the right part, the subtrees that I have in the left and the right, and I get the diameter from the left and the diameter from the right subtree. So if I have these four values, I can make the calculation at the root, right? How will I make that calculation? So we'll see more in more detail when we code it. But the basic idea is that if you are able to get like if it is a case that your diameter is in the left part of the subtree, then at the root you will calculate whichever is the maximum diameter from the left and the right, and then you'll return the answer. If it is not the case that diameter neither exists on the left part of the sub tree, that is the left subtree, and neither the diameter exists in the right subtree, then it is the case where the diameter passes through the root, right? Now if it passes through the root, then in that case the height of the left plus the height of the right would be my diameter of the tree. It would be the final answer, going from one of the nodes in the left part of the subtree, going till the root, and then going to one of the deepest leaf node in the right part of the subtree. So if like this is clear to you, you should have some intuition about it. But to get more clarity, let's get to the code part of it. Okay, so as I said, right, I am going to need two things. I am going to need the diameter from the left subtree and the diameter from the right subtree. Then I'm going to also calculate the height of the left subtree and the height of the right subtree. So that means in every recursive call, I'm going to have these two answers with me, right? Now you can use like any way of having these two parameters maintained in your recursive stack calls. I'm going to use like a custom class pair. Mostly I use that sort of thing if I have to maintain variables at every recursion call stack. So what I'll do is I simply like create a pair. You can use inbuilt pair also, which is present in Java. I'm going to not use key value. I'm just going to name it what is height, what is the diameter, like that. So that's why I'm like creating it anyways. Whatever you are more comfortable with, you can do. So I'm going to create these two attributes of this class pair, and I'm going to quickly create a constructor. This one is your default constructor that I'm going to use initially, and then this one is going to be my parameterized constructor, and I'm going to do something like this dot. Okay, equals to h this dot Okay. Now let's go to this original class of ours. Close this. Okay. So my function is going to return this pair class, and from this pair I'm going to finally return the diameter. So I'm going to create a helper function, right? So I would do something like this pair, and this is going to get me the diameter, and I'm going to pass it the tree node root. Okay. And what I'm going to basically do is from here I'll call this function diameter. I'm going to pass the root and then return the dot. Yeah. This should be my final answer, right? Now let's see how will things work in this. So basically, what you are going to first like do is handle the base case, right? The base case and the edge case in this case. So let's think of it. So the first case is that let's say your root is equal to null. What will you return? What will be the pair class diameter height? How will you keep it? So consider the scenario that think of it that let's say your root is null, your current node is null, then what should ideally be the height? Height is 0, right? I am considering that the single node is present. Let's say there's nothing in the tree, there's just one single node. The height of that node is 1. Okay, whereas there is no node, then the height of that node is 0. Okay, so if I have to create a pair for this one, so my height is 0. What is going to be my diameter? So diameter is essentially, as we discussed, the distance between two nodes, right? Now, for a tree, the diameter is the maximum distance that you can have between two nodes. But in normal case, when you are saying that your node is null itself, is considering a diameter even a valid case? It is not, right? Because there's not even a single node. So that is why I'm not keeping diameter as 0. I have to keep diameter as -1. Okay, and we'll come back to it. I'll tell you like how not keeping it -1 can give the wrong answer. But for now, consider that there's not even a single node present, and that's why the height that I'm keeping for this is 0, and the diameter is going to be -1. Okay, and I'm going to return this p. Another case, let's say you are at the leaf node. What does this mean? If you are at leaf node, that means your right is equals to right? That means your left and right children are nothing. Those are like null values. What will be your pair returning in this case? Actually, in this case, what you will see is you have one single node. So as I said, if one single node, I'm considering it to be as height as 1, right? So height 1, the first parameter h. Okay, diameter, this is one node, and the distance between one node and any other node which is not present, it is not going to be -1, it is going to be 0 in this case. Like you can think of it as that okay, let's say your question is given just one node, then what would be the diameter that you will be returning for that? Like consider that there is no node, there's just one node, there's no children. What would be the diameter would be 0, right? So that is why you have written the height to be 1 but the diameter is 0 in this case, and then you're returning it. Okay, now let's see how we'll make the calculations for the generic case. Okay, so first of all, let me make the calls to left and right, right? Because we need to have the answer from the left and we need to have the answer from the right, right? So I need to go to the roots left, and I'm going to get the answer from there, and then pair right diameter. Okay, I'm doing a lot of spelling mistakes. Root dot right. Now, considering that you have the answers, the diameters and the height from the left and the right, how will you make the calculation at the root to return your final answer? This is the calculation that we are going to do now. Okay. Now, what you'll do? You'll have a uh, let's say that you need to calculate the final height and the diameter, right? So, int height is equals to, just a second. Yeah, sorry for that. So I was saying, yeah, you have to calculate the height, right? So the height at the root, when you are given the height from the left and the height from the right, is going to be obviously the maximum of both, the either from the left or the right, whatever the maximum is, that is going to be your height plus one on that, right? For the distance between them. So max dot max. This is going to be L dot height, comma R dot height, whatever the maximum is, and then plus one on that. And your diameter, that is going to be, so what is going to be the diameter at the root if you have the height and diameter from the left tree and the right subtree? It is actually going to be either the diameter or the final answer is on the left or the right. So math dot max of left's dia or right's dia. That is the one situation, right? Where the answer is in the left subtree or the right subtree. So return the max of that. If the answer is not on the subtree, that means it passes through the root. Then in that case, you have to deal with the heights. So what you'll do is you'll return L dot height plus R dot height. And finally, you'll have your pair answer and to be new pair. You'll have the height, you have the dia, and you're going to return the answer. Okay, and see how I have not even written new keyword here. Strange. Okay, so this is how it should be. Let's check if we have not mixed on anything here. Get the diameter from the left, get the diameter from the right. Height is going to be the max from the left and the max from the right plus one, either of them. Okay, and the diameter is going to be left height plus right height, or the maximum diameter from the left or the right subtree. Then you get the answer and you return the answer. Looks good to me. Let's try running. Okay, this got accepted. Let's try submitting it. Okay, okay. So, yeah, the question is done. I hope you enjoyed it. So, basically, the important thing to note here is that how are you dealing with getting the heights and the diameter without making extra calls, right? And how you are making the calculation at the root if once you have both of these values, the diameter and the height from the left and right subtree. So time complexity of this would be O of n, right? And space complexity of this would be that since you're going through the recursive call stacks, so it will depend on the height of the tree. If it is skewed, it will be O of n. If it is a balanced binary tree, then the calls would be O of log n. So you can say the time complex, the space complexity is O of height, right? Okay, so this was it for this question. Hope you have understood a little bit. I'll see you in next question some other day. Thank you. Thanks for watching. Bye bye.